Hey everyone, I'm Joshua Deemer and welcome back to Lesson 5 of our Java Programming Tutorial Series. Let's jump right into the lesson. First, let's discuss something really quick. This is an assigning equals, and this is a comparison equals. The first equals assigns a variable a value, while the second equals checks to see if that variable is equal to the value on the right-hand side. Let's take a look at what I mean by that. So here I've initialized a boolean, and if you recall, a boolean is either true or it's false. Now this boolean is checking is 5. So we're saying this is equal to 5, check if it equals 5. Well, that's real confusing, so what does that even mean? So it's checking is 5 equal to 5. Okay, so that's what this here is doing, is 5 equal to 5. And so since it is, it's true. Therefore, is 5, the variable, is equal to true. Okay, so we're first of all checking if 5 is equal to 5. Then we're setting is 5 to whether or not that's true. Okay, now how do you check if something isn't equal to something? Well, you just put exclamation point equals there. So is 5 not equal to 5? That is false. So therefore, is 5 is equal to false. This is how comparisons are stored inside of Boolean variables. Now, there are 4 other comparison operators than equals, equals, and not equal. There is greater than, lesser than, greater than or equal to, and lesser than or equal to. So here I've made 2 variables that are integers. They both store 5. And so over here I'm checking to see if these comparisons are true or not. So firstly, we're checking if number 1 is equal to number 2, which is true, because 5 is equal to 5. Okay? This one, number 1 does not equal number 2. This is false, because 5 does equal 5, right? This one, see, number is greater than number 2, or number 1 is greater than number 2. This is false. Okay, remember, greater than is not greater than or equal to. We're checking to see if 5 is greater than only greater than 5. Okay? This one's the same way. It's false because it's not lesser than, it's equal to. Now this one is greater than or equal to, so this is true. This one is less than or equal to, which is true because they are equal. Now let's change one of these numbers. Let's say this is 7. 5 and 7. So the first number is no longer true. The second number is true because it's not equal. The third number is false because 5 is not greater than 7. The fourth number is true because 5 is less than 7. The sixth number is false because it's not greater than or equal to. The final number is, or the final variable is true because 5 is less than or equal to 7. Okay? Now remember, these are just the comparisons. We are now storing this false into A. We're storing this true from this result into B. We're storing this false into C. I don't want you to get confused about that because we see a lot of equal signs here, don't we? But we don't get too confused over that, alright? Now let's get a little bit of experience in with this. So here I've said create 2 integers with different numbers. Create 3 booleans, which must all be true in regard to the integers. So the result must be true and must be unique. Okay, so you can't just have 2 equals equals. You must have them all unique. Print the results to the console, and create 3 more booleans, which must all be false in regard to the integers. Again, they gotta be unique. You can't just say equals 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 equals. You can't just say not equals not equals. You have to have them all unique. Then print those results to the console. If you want to do this on your own, pause the video and come back, but we are going to go over it right now. So we're going to create 2 integers. We'll call them first equals 1. We'll do 0. And then int second is equal to 2. Okay, now let's create 3 booleans which must all be true. So boolean true 1 is equal to first does not equal second, because this is true. Boolean true 2 is equal to first is greater than second, because that's not true, because first is 0. And boolean true 3 is equal to first greater than or equal to second. Now let's print these out. So system.out.println true 1. I'll just paste the line 2 times, then true 2 and true 3. Now let's have boolean false 1 is equal to first equals second, because first doesn't equal second, so this will be false. Boolean false 2 is equal to first is lesser than second. Oh, did I mess up? I think I messed up. Oh, good thing I caught that before it ran, otherwise that would have been really embarrassing. Is greater than, because the alligator teeth, if you remember in elementary middle school, don't want the first, they want the second, because they want more. So boolean false 3 is equal to first is greater than or equal to second. Okay, now let's print them out. Print line false 1. Now let's copy this line twice, false 2 and false 3. Now this should print out true true true, false false false. Alright, we succeeded, it looks like. So that's how you do this. Hopefully this helped you understand Booleans and comparison operators better. Now let's go ahead and discuss 3 logical operators. The first one is not, then we have and finally or. So how does this not operator work? It might seem a little confusing at first, but let's go ahead and take a look at making another boolean here. So boolean b equals true. Well, this b is always going to be true, but what if we wanted to make it false without using the word false? All you do is you use the not operator, and this inverts the boolean. So what was now true is now, or what was true is now false. If I try to print this out to the console and run it, save the resources, it now says false because I've inverted the boolean. So now let's take a look at A. Let's say B equals A. We run it, it says true. That's because first does equal second, because 5 and 5. 5 does equal 5. But if we say not A, or invert A, it's now false. You don't need to do it on something as simple as this. You can also say not, and then add parentheses around the entire statement that you want to invert. So now, if I say B equals A, and run it, it's false now, because this is inverted already. If I say not again here, it'll revert back to true. So all not does is it reverts the boolean from true to false. And you can do it in here as well. If I run this, it'll say false now, because this is true, this makes it false, this makes it true, and this makes it false. Well, let's start making this a little more complicated now. So I have my first and second just like before, but I added a third, which is 10. So Boolean A is the same, it's going to be true. Boolean B is going to be true as well. However, Boolean C is not true because second times 2, which is 10, is not greater than third. Remember, if we had greater than or equal to, this would be true, but it's not equal. We don't have the equal to, and it is not greater than third because second times 2 is 10. Okay? So let's take a look at these more complicated operators. So we have and or. Or is pipeline, which is you hold shift and it's just above your enter key, for most keyboards at least. Now, let's say we want to check if this one and this one are true. Okay, this would be, all you say is A and B. Then what if you want to say or? You would say A or C. Okay, so what this does is it checks if this Boolean is true and this Boolean is true. If they're both true, then the result in general is true. Otherwise, it is false. With this one, we're checking if A or C is true. So either or both could be true. If none of them are true, then this one's false. Okay, so is A true? Yes, it is. Is B true? Yes, it is. So therefore, this statement is true. Is A true? Yes, it is. Is C true? No, it is not. But since we're not doing and, we're doing or instead, one of them is true, so it's true. Now, if we went ahead and turned this into and, this would now become false. So that's how these logical operators work. Now, what you can also do is you can say if not and or C. This would now be false because A was true, but then it became false with the not logical operator. This was already false in the first place. If I did this, this would become true because this was false, but now it became true. Okay, so logical operators are this simple, but they can become much more complicated. If we go ahead and say A and B or C and not B or not C, you can see how this can become a whole lot more complicated. Not only that, but we could add parentheses in. And these parentheses would change the order of how these run. Because then we would check, is B or C true? Then we check, is A and B or C true? Then we check if this is true as well as this is true. Then we check if this is true or if this is true. And it can get complicated. So these parentheses can help out. It can confuse people. But overall, if you got the gist of it, then that's perfect. Now, make sure that you don't confuse yourself between and the bitwise and, or, and the bitwise or. All these do is compare numbers, binaries together in terms of are both bits 1 or if either or are 1. These ones are logical based and they work with booleans. So do not confuse the two. Now let's discuss one of the most important things inside of programming. Branching statements such as if, else if, and else. The syntax for an if statement is if, then parentheses, boolean, then you have your curly braces. Outside of those curly braces, you have else, if, more parentheses, and then a boolean. Then you have your curly braces again. Then you have else, and then one more pair of curly braces. Let's explain this a little more in depth. So with if statements, these are branches in your code to where you say, if this is true, run this code. Otherwise, don't run this code. So if I were to say if 5 equals 5, and then add my curly braces, anything inside of these curly braces will run if this Boolean here is true. Now this is always true, so the inside is always going to run. I could also say if 4 equals 5. Then you'll see that Eclipse gives us some warning where it says dead code. This will never run because this is never true. So if we have an integer number 1 is equal to 5, integer number 2 is equal to 5, then Boolean a is equal to number 1 equals number 2. Alright, now let's use a here. We say a equals true. Well, now we know that this is always true, so this will always run. However, we're comparing to see if it's true. You can simplify your Boolean to simply say if a. This will assume that a is going to be true. Now here's the same thing. You got if a equals false or if a does not equal true. All you need to do is say if not a. Then this will run if a is false, which will never be true. So let's go ahead and add some code into here. So system.out.println a is true. Alright, let's run this. A is true. Well, of course it is, because we made it so that it's always true. But what if we change one of these numbers to 6? Now, nothing runs. It is simply not going to print this statement because it's not true. With an else if, however, you can, or let's go ahead and do else first. If you have else with a parenthesis, if this statement is not true, then this will always run. Okay? Whatever's inside of these braces will run. So if I say system.out.println and say a is false, and I run this, a is false. This did not run, but this ran instead. Okay, let's make this a little more complicated. Alright, I'm going to remove this Boolean, and we're going to say if number 1 is equal to number 2, then say equal. Otherwise, if number 1 is less than number 2, and say less than. Now, what will run? If we run this, nothing runs, because number 1 is greater than number 2. So if we say else if number 1 is greater than number 2, we'll say system.out.println greater than. We run this, it says, oh, greater, lesser. Let's run this again. It says greater than. If we change this to 4 and run it, it says lesser than. If we change this to 5, it says equal. Now, I didn't need to add this else if. I could have just simply said else. So what this would do is it would check if this is true. If it's not, then it'll check if this is true. If it's not, then it'll always run this. You can have no else so that it'll just continue your code down here. So system.out.println exit. This way we can see what I mean. We run it. It says equal, then it says exit, because it skipped over this code since this was true. If we say else if number 1 is greater than number 2, so we'll add this back in again. Println greater than. And we run this. it'll still say equal exit because this is not true. Even if, so let's say we make it so that all three of these are true because this is now true and this is now true. We run it, it only says equal because this will only run if this one's false. If you want all three to run, then you remove the else and you just have the ifs, like this. If you run this now, it'll say equal, lesser than, greater than, because now there's no else hindering it. And you can add else's to each individual if. You can have nested ifs, so you can have an if inside of an if, but people don't generally recommend that when you're a little more stable in your coding. Now that we've familiarized ourselves with if, else if, and else statements, let's go ahead and do some practice. Again, if you want to do this on your own, feel free to pause the video after I explain it. So, create some integers and booleans with values determined by the integers. So for example, if you have 5 and 4 as your integers, have the 5 equals, greater than, lesser than, that kind of thing. Then create an if, else chain with 2 else ifs. So I want if, else, else. Okay? Then each curly brace section should print something unique to the console. So each if, and else should print something unique to the console. So there should be 4 different things printed to the console if that certain area is true. Okay? So pause the video here. Otherwise, we'll get right into it. So let's create a couple integers. So int first equals 1, int second equals 2, boolean first if is equal to first equals second, boolean second if is equal to first is greater than second, boolean third if is equal to first plus 3 is greater than second. Okay, that'll work. So if the first if is true, then let's do something. Let's go ahead and say system.out.println. Hello there. Otherwise, if second if is true, then system.out. not append, print line. Oh my goodness. Let's say first plus comma plus second. Do a little concatenation in there. And we'll say else if third if system.out.println. And we'll say goodbye. Otherwise, say system.out.println. None were true. Alright, so now I'm gonna guess which one's gonna print. I believe this one will print. So let's run it. Ah, I was correct. Goodbye. Now, I could also add not here so that I can demonstrate what this would say. If we run this, it says 1, 2. Alright. What if I add nothing there? It should say 12. But if I remove the string in general, it'll say 3 because now we're adding 2 integers together. If I say, however, a string in front, it should say 12 again because now I'm adding it to a string. Don't get too confused about that, okay? Once a string is involved, then it generally converts the entirety into a string. So now we're just adding the string of 1 and the string of 2 together, rather than 1 plus 2, which is 3. Let's talk about scope for a quick second here. So, taking a look at this, it looks a little confusing, so let's break it down a bit. So we say if true, which this will always run then initialize a variable A. If true, which is always true, initialize a variable B to 0. if true, final time, then initialize C to 0. If any of these are false, then don't initialize A, B, or C. If this one's false, then don't initialize B or C. If this one's false, then don't initialize C. Alright, then I got D here, which does not have any default value. Now, the way that scope works, let's go ahead and say equals A plus B plus C. You'll notice that all three of them are underlined in red. That is because of scope. The way it works is, if I were to break this down really simply, and some people might get mad at me for explaining it this way, but I'll do it for simplicity's sake. This gets stored inside of RAM within these braces, these curly braces. At the end of it, try to interpret it as if it's getting released from RAM. This is not 100% accurate. However, as a beginner, that is a great way to understand it. This is getting stored inside of these curly braces. And then at the end, once this curly brace is reached here for A, it basically gets deleted and it can no longer be used outside of this scope. The same is true of B here. If I were to say move this up into here, you'll notice A is now valid because it is within the scope. However, it's outside of B's and C's scope. If I move this up, you'll notice that B is now no longer underlined, but C still is because the scope of C is here. And this includes the scope of this, because eventually we will be making, if I can spell, we'll do void hello. We'll be making more of these. And so integers made in here cannot be used inside of here because this scope is different from this scope, and it works the same vice versa. Keep that in mind when you program. For our final section, let's go ahead and discuss the switch statement. This one's a little more confusing than an if statement, but we'll go over it nonetheless. The syntax for it is switch, and then you put in an integer, a string, things along those lines. And then you write down the cases and break each case. Otherwise, you have the default case. Let's go ahead and take a look at a switch statement. So we made a string here called hello, and it stores the string hello. Very unique. And so inside of our switch statement, we put in this string variable. Now, not all variables are accepted by switch statements, but strings are one of the data types that are accepted. So here we check if the case is hello with a capital H and a capital O. If it is, then print out first. Then we check if the case is hello with a capital H. If it is, then it's second. If it's all lowercase, then third. If two L's are uppercase, then fourth. Otherwise, for all other cases, we print out default. Let's go ahead and run this and see what it does. So it says third, fourth, default. That's because it runs here, but then it runs all the ones after it. Well, in order to stop that from happening, we need to add the break word. If we run this now, it'll only run third. Now, it's the same case with, let's say we did the second version, hello with a capital H. Run this, it'll say second, third, and stop at third because we break there. So let's add a break here as well. In fact, let's add a break to all of them. So break. No. Come on. Break. And break. So now you can see second works perfectly fine. But what if I say goodbye? Now the default catches it. Okay, so you can see how this kind of works like an if-else. But switches are more optimized for conditions. Okay? It's just they aren't as versatile as an if statement. For example, I'm not going to be able to say int a equals 0, a, and then I say 0. It's checking if the case is 0, but it's not checking if the case is greater than 0. Okay? You can also do ORs, saying case 1 right after the case 0. Then if the case is 0 or 1, then it'll run first. Now let's go ahead and practice with the switch statement. So first off, create a string with your first name in it. Add a switch statement with 3 cases and a default case. These cases can be whatever you want, but if you don't know, just do different variations of your name. And then print something unique out for each case. Okay, so let's create a string. First name is equal to Joshua. Then let's go ahead and say switch first name. Okay, we've got it plugged in, so let's type in case, and we'll do lowercase Joshua. Then system.out.println lowercase. And then we'll break. In case Joshua system.out.println normal. Then break. In case Joshua and system.out.println uppercase. Break. And default system.out.println none of the above. And break. Let's go ahead and adjust these so they match. And let's go ahead and run it. What should run is normal. Yay! Now, if we lowercase it, lowercase. If we capitalize the whole thing, uppercase. If we do some weird more for add a space, say into it, it'll say none of the above. Awesome. Keep in mind, this here is also a scope. Anytime you see curly braces is a scope. In fact, you can have curly braces without anything attached to it. You can see there's no errors here, but this is outside of the scope for it. That's the end of this episode. Next episode, we will be covering lists and arrays in Java. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!